All right, welcome to another deep dive where we, try to cut through all the noise and get right to the good stuff, the real heart of the matter.
The insights.
The
Yeah.
insight, yeah, exactly, the insight. So today's focus is on operational excellence in the world of Microsoft Azure.
Yeah.
And we've got a really a really good mix of sources for this one. So we've got stuff from the official Microsoft Learn documentation
Oh, yes.
about the Azure Well-Architected Review and all that good stuff.
Yeah.
We've also got discussions and sort of walkthroughs and explanations from Microsoft experts on YouTube.
Excellent.
So our mission today is to understand how to really run our cloud workloads well,
Right.
not just functionally, but exceptionally well.
Yeah.
So the key principles, the practical tools, all within the context of Azure.
Exactly.
So if you're looking to gain that knowledge quickly, efficiently,
Avoid information overload.
avoid the overload.
Yeah.
Have those aha moments
Yep.
about cloud operation. Right. Then this is the right conversation to be a part of. So
Absolutely.
the first thing that really jumps out is this idea of operational excellence being really rooted in this idea of DevOps practices.
Absolutely.
And of course, DevOps is that fusion, that sort of blending of development and operations. And it's really about ensuring high quality workloads through standardized workflows and just a strong sense of teamwork.
Absolutely. That's really the core of it. Yeah.
Yeah. So this pillar, this operational excellence pillar of the well-architected framework, really focuses on the development practices, the observability,
Right.
and how you manage your releases.
Release management.
Release management, yeah.
Yeah.
And it's all about trying to reduce those inconsistencies, minimize human error,
Yeah.
and most importantly, avoid disrupting your users.
Yeah, absolutely. So you want to make sure that things are running smoothly, that the users are having the good experience, that you're not, introducing errors, you're not having downtime, things like that. And
Right.
so yeah, that's really the core focus of operational excellence.
Okay, so it's not just about getting your applications running in the cloud.
Yeah, right.
It's about operating with precision, with foresight,
Yeah.
with an understanding of how everything's working.
Yeah.
And it sounds like there are some fundamental design principles that really guide this.
Right.
The first one that caught my eye is this idea of using common systems and tools.
Oh, yeah.
Why is that so important?
Yeah. So using common systems and tools is really about fostering that collaboration that we were talking about, breaking down those silos between development and operations.
Right.
Encouraging communication between the teams. And so, if everybody's using the same dashboards, the same tracking systems,
Right.
You have that shared understanding of what's going on.
Right.
Everybody knows the escalation paths because it's the same across the board. And if your teams are all proficient in the same suite of tools,
Right.
they can move between different environments and work effectively and it just streamlines everything. It makes things a lot more efficient.
It's almost like having a universal translator.
Right.
For your teams.
Exactly.
So everybody can understand each other.
Yeah.
The next principle here really emphasizes building a continuous learning and experimentation mindset.
Oh, yeah.
And that feels so vital in the cloud because it's always changing,
Absolutely. Yeah. The cloud is a very dynamic environment. It's constantly evolving. And
Right.
so you have to have that commitment to continuous learning to stay ahead of the curve. You got to be promoting knowledge sharing within your teams. Make sure your documentation is up to date, readily accessible. Do blameless post-incident reviews.
Right.
When things go wrong, which they inevitably will, focus on extracting the lessons learned and improving, not on assigning blame.
Right.
And then also encouraging experimentation. Things like A/B testing, proof of concept projects, things like that, allow for innovation,
Right.
but in a controlled way.
Right.
And you're always looking for better, more efficient ways of operating.
Right. Learning from both successes and failures.
Yeah.
And then this idea of adopting proven industry agile practices.
Right.
How does agility contribute to operational excellence?
Agile methodologies are really about optimizing actions. And so if you can embrace those agile practices, you can really identify opportunities to shift left in your operational consideration.
Shift left. What does that mean?
So shifting left basically means, integrating your operational aspects earlier in the development life cycle.
Okay.
So, if you can integrate things like automated testing, security checks, even observability setup, earlier in the development process, you're going to be catching potential issues much sooner,
right?
And you're going to be resolving them much quicker,
right?
And that's going to lead to shorter release cycles, which ultimately means delivering value to the business more quickly.
Right. So addressing those problems upstream,
exactly,
rather than waiting until they're downstream. Yeah. Okay, got it. So shift left, address those problems before they become major issues.
Exactly.
Another key principle that I see here is setting standards for all development and operational procedures.
Yeah.
That sounds like a huge effort, but also, probably very beneficial in the long run.
Yeah, it's definitely an upfront investment of time and effort, but it's well worth it in the long run. If you have clear standards for everything from your routine tasks to the tools that you use to your monitoring protocols to even how you communicate with stakeholders, it brings a remarkable degree of predictability to your operations.
Right.
And it makes your processes and your practices inherently more scalable.
Yeah, right.
And then, if you're deliberate and transparent about your decisions and you're regularly reviewing and validating these standards, you can continuously identify areas for improvement and prevent those unexpected anomalies that can introduce risks.
Well.
And of course, it's always important to practice for unforeseen events. So doing routine drills,
right,
to make sure that your teams are ready to respond to any kind of incident.
Okay, so predictability, scalability, paramount in the cloud.
Absolutely.
And then the final principle here is taking advantage of centralized operations teams. How does that contribute to operational excellence, especially when often you have teams that are very focused on their specific workloads?
Right. Well, centralized operations teams can offer specialized expertise and a wider perspective that individual teams might not have.
Right.
And there's cost benefits to leveraging shared resources for things like incident management,
right,
proactive monitoring,
right,
access to niche technical skills. So while your dedicated workload team maintains ultimate ownership of the application,
right,
the centralized team can provide invaluable cross-functional support and guidance. They're essentially acting as an internal center of excellence.
Right.
But, it's also important to make sure that these centralized teams don't become bottlenecks,
right,
or lose touch with the specific needs of individual workloads.
Right. Okay. So those are the foundational design principles. Now let's dig into this idea of observability.
Yeah.
And I know it's described as being essential for anticipating problems. And the documentation really emphasizes using health modeling for this.
Right.
So can you explain what that means?
So health modeling is about establishing a clear understanding of your workload's normal operating state.
Okay.
And then defining specific indicators that can signal when things are deviating from that baseline, potentially leading to an incident.
Right.
So effective monitoring is really the bedrock of this. It allows you to be proactive,
right,
rather than reactive in addressing potential issues.
Right.
So you're not waiting for something to break.
Right.
You're actually looking for signs that something might be going wrong, and you're addressing it before it becomes a problem.
Okay. And how do you actually, construct this type of monitoring system?
Right.
The outline here highlights several key approaches.
Yeah. So one fundamental approach is to architect your monitoring system with its own independent infrastructure and data pathways.
Okay.
So you're treating your monitoring capabilities as a separate yet equally vital dimension of your workload. So this independent system needs to encompass all layers, from the underlying infrastructure to the health of your application, even your software delivery pipelines. And it's important to note that while you're closely tracking application health, directly capturing business metrics is generally considered outside the scope
Okay.
of technical observability.
Okay.
And so you want to keep those systems decoupled,
Right.
so that they can each evolve without impacting the other.
Right.
Imagine your application and its vital signs being tracked by a completely separate medical team.
Right.
If something happens to the patient, the doctors are still there,
right,
unaffected,
right,
providing crucial information.
So that separation makes a lot of sense.
Yeah.
Because you wouldn't want a problem with your application to also take down your ability to see what's happening, what's going wrong.
Right. Exactly.
What about this idea of actually gathering data? How do you make sure that you're getting information that's both consistent and useful?
So establishing consistency in data collection across all your different data sources is paramount. So this involves, standardizing how you instrument your application code, adhering to industry best practices for telemetry, and ensuring a uniform methodology for collecting infrastructure metrics. And so when your data collection is consistent, it becomes significantly easier to correlate information from various sources, which in turn accelerates analysis and helps you more accurately predict potential problems.
Right. So you get that holistic, that unified view
exactly
of your system's behavior.
Yeah.
The outline also emphasizes emitting telemetry directly from the application code. What kind of information should developers be building into their applications to provide this insight?
Embedding telemetry within your application code gives you an end-to-end perspective on how your application is functioning. And so this telemetry should link together, key points in the execution flow and offer, varying degrees of detail from high-level summaries to granular traces of individual requests. And so this information is invaluable for troubleshooting,
right.
And it allows you to understand the context of events,
right.
Based on their level of detail. It allows you to prioritize actions based on the severity of the reported issues.
Right. So actively building in the capability to observe
exactly
the inner workings of your application.
Yeah.
And who carries the responsibility for making sure this data is actually being gathered and made available?
Right. So the core principle here is to take ownership of both emitting and collecting your observability data, even if the underlying data storage or syncs are shared across multiple teams and managed centrally.
Okay.
So by keeping that initial data capture localized within the workloads environment, your specific team has direct and immediate access to the logs and metrics that they need to address their unique concerns and understand their system's behavior.
Right. Okay. So each team is directly responsible.
Yeah.
For their own
observability data.
Observability data.
Right.
Now we all know that monitoring can generate a really massive amount of data.
Oh yeah.
So how do you avoid being overwhelmed by this deluge,
right?
And also prevent incurring all these unnecessary costs associated with storage and processing.
Yeah, so that's where the principle of collecting just enough data and retaining it for just enough time becomes crucial. You need to be deliberate and strategic about what data you choose to collect and carefully consider the financial implications associated with logging and storing it.
Right.
And so this helps you optimize both your operational and your financial costs by avoiding capturing more data than you genuinely need for analysis and alerting.
Right. Right. So being selective about what you track and how long you keep it.
Exactly.
The outline then goes on to break down these different types of monitoring signals. So we have, metrics, we have profiles, we have logs and traces.
Yeah.
What's the fundamental difference in how you should be leveraging these?
Right. So metrics are are most effectively used for triggering automated actions.
Okay.
Because they provide quantifiable measurements of your system's health and performance over time. So think of things like CPU utilization, memory consumption, request latency,
Right.
things like that. Profiles, on the other hand, offer a much more granular, low-level view into the system's internal operations. So things like memory allocation patterns or CPU instruction execution. And so these are incredibly valuable for in-depth investigations and performance tuning.
Okay.
And then finally, logs and traces serve as your primary sources for providing rich context around specific events and understanding the intricate pathways and dependencies within your distributed system. And so by strategically using each signal type for its intended purpose, you can avoid inefficient implementations of your monitoring system. For instance, trying to trigger immediate alerts based on parsing through verbose logs can be far slower and less reliable than setting thresholds on aggregated metrics.
Got it. Okay, so metrics for immediate sort of
automated
responses.
Exactly.
Profiles for those deep dive investigations, and logs and traces for the essential context.
Right.
Okay. Now, once you've accumulated all this data, how do you make sense of it and turn it into actionable insights?
So aggregating and visualizing your data in thoughtfully designed dashboards is absolutely essential for making it understandable and actionable.
Right.
So you wanna create situational dashboards that provide a high-level overview of key performance indicators for stakeholders, always keeping the overarching business context in mind. For the operations teams who are on the front lines responding to incidents, you need operational dashboards and workbooks that offer drill-down capabilities, allowing them to investigate issues in granular detail. These dashboards should be updated frequently and present data in a clear, concise manner.
Right.
Well-designed visualizations help you quickly identify trends, track progress against your business objectives, and manage incidents far more effectively.
Right. So tailoring the dashboards to the specific audience.
Exactly.
And providing the appropriate level of detail.
Yeah.
Okay. And finally, what about getting notified when things deviate from the norm?
Right.
How do you make sure that your alerts are actually helpful and not just adding to alert fatigue?
Yeah, making your alerts truly actionable is paramount. Notifications should be routed to the specific teams or roles that are accountable for the affected systems. And they should include standardized descriptions and clearly defined severity levels, incorporate relevant information from various sources to provide immediate context, highlight any deviations from established business targets. Most importantly, configure alerts to trigger only for incidents that genuinely require immediate intervention.
Right.
You should be striving to implement proactive alerts that can initiate automated remediation actions before a degraded state escalates into a full-blown service disruption.
Right.
So a well-designed alert system acts as an early warning system, providing just enough pertinent data for operators to understand the core issue and begin the necessary remediation steps without unnecessary delay or noise.
Okay, so actionable, proactive, and not overwhelming.
Exactly.
That sounds like a good recipe.
Absolutely.
For an effective alerting strategy.
Yeah.
Let's shift gears a little bit and talk about how you actually build and deploy your workloads in the cloud.
Right.
This idea of the workload development supply chain and the team's overall accountability for that.
Yeah.
What are some of the fundamental aspects of this?
So the central idea here is that the team that's responsible for developing and maintaining a workload also takes responsibility for all the stages involved in moving that workload from initial development all the way into production.
Right.
And so one of the foundational practices in this area is to adopt infrastructure as code.
Okay.
often referred to as IAC.
IAC.
And so this involves defining your entire infrastructure, your servers, your networks, your databases, everything,
Right.
in a descriptive model using a version control system,
Okay.
much like you manage your application source code.
Right. Right.
And so you should strongly favor declarative approaches,
Okay.
where you define the desired end state of your infrastructure
Mhm.
over imperative methods,
Or-
where you explicitly spell out the step-by-step actions to take.
Okay.
So think of it as providing a blueprint
Right.
rather than a set of manual instructions.
Okay.
So you're not saying, go here and click this button and then go here and type this command.
Right.
You're saying, I want my infrastructure to look like this.
Right. Right.
And the IIC tool will figure out how to make that happen.
Okay. So why is this shift to IIC? Why is it so beneficial for achieving operational excellence in the cloud?
Well, declarative ISE technologies are inherently designed for automation and reusability.
Okay.
And so it allows you to offload the complex and error-prone task of infrastructure provisioning from manual, click-based processes to automated tooling, leading to dramatically more consistent and reliable deployments.
Okay.
From an operational standpoint, having a well-defined and version-controlled description of your infrastructure significantly reduces variability.
And makes it much easier to detect and address configuration drift.
Okay.
Those subtle, unplanned changes that can lead to problems down the line.
Right, right.
Maintenance also becomes simpler and more predictable. And if you align your IAC technology choices with your team's existing skill sets, the adoption process becomes much smoother and more efficient.
Right.
So think of IAC as bringing the rigor of software development to your infrastructure, ensuring not just consistency,
Right.
but also auditability and the ability to quickly reproduce environments,
Right.
which is a game changer
Yes.
for disaster recovery and scaling.
Okay, so greater consistency, seamless automation, simplified maintenance.
Yeah.
But just having the right tools in place, it isn't enough, right?
It's not.
The team needs to know
Right.
how to use them effectively.
Right, absolutely, yeah. You need to prepare your team to effectively leverage the chosen IAC technology.
And so this includes, gaining a deep understanding of its extensibility model, its core capabilities, and any inherent limitations. Encourage the development of specialized expertise within the team, and cultivate an environment of shared knowledge across the organization. Investing in upskilling your team not only boosts productivity, but it also fosters better collaboration through shared understanding, and you can potentially bridge skills gaps without the immediate need for new hires.
Right.
If you can train up your existing team on the new technology, then you don't have to go out and hire somebody new.
Right.
Who already has that expertise.
The outline here highlights the importance of following established software development recommendations, specifically for IAC. So what kind of best practices are we talking about?
So you want to apply the same level of engineering rigor and best practices to your IAC code base as you do to your core application code.
Right.
So this includes modularizing your IAC definitions thoughtfully.
Okay.
Striking a balance between avoiding overly complex abstractions that add unnecessary overhead.
Right.
And ensuring that your code is well organized and maintainable.
Okay.
You should also follow a layered approach.
Okay.
Structuring your infrastructure definitions to reflect different phases and dependencies. So, for example, your foundational layers that rarely change should be logically separated from your application and data layers, which might require more frequent updates.
Right.
And critically, remember that your deployment artifacts, such as your IEC templates
and your application binaries are integral parts of your overall attack surface.
Right.
So you must apply stringent security measures, including robust secret management and fine-grained access control to protect them.
So treating your infrastructure code with the same care and attention as you do your application code makes a lot of sense.
Absolutely.
For overall system integrity.
Yeah.
Another key point that I see here is developing a common deployment manifest. So what's the primary purpose and benefit of having this?
So a common deployment manifest serves as a single authoritative source of truth.
Okay.
That describes precisely how your workload should be deployed consistently across all your different environments.
Okay.
From initial development and testing to the production environment.